After giving you a brilliant example of your pocket money, let me tone down to the idea of decay constant and the half-life. Believe me, it's a very methodological phenomena and the theory. Well. Decay constant, that is lambda. I want the idea of lambda, so I gave the idea of decay expressions. That is dn by dt, rate of disintegration, is equal to minus lambda n, where the decay constant is defined as a ratio of the amount of substance disintegrating per unit time to the amount of substance present at that time. Okay, fine. So you mean to say lambda is equal to dn by dt upon n with the minus sign. So we have n is equal to n0 e raised to minus lambda t. And putting these values, okay, n is equal to n0 e raised to minus lambda into 1 by lambda. Now what is small t is equal to 1 by lambda? It's a reciprocal, it's a mean life. Okay, so n is equal to n0 e raised to minus 1, or n is equal to n0 by e, or n is equal to n0 upon 2.718, or n is equal to 0.37 n0. This is for mean life. Okay, now, so decay constant can be defined as a reciprocal of the time in which the substance decays to 37% of its original quantity. The basic idea of decay constant. Now, proceeding forward, what is half-life? Simple graph will explain the entire idea. I am plotting a graph of time versus number of atoms present. Let's say at 0, n0 atoms were present. After first half-life, that is t, half of n0 will be remaining and half will be disintegrated, that is n0 by 2. After second half-life, let's say it takes place after 10 days or 1 day or 10 years, half of n0 by 2, that is n0 by 4, will be remaining. So I will join these 2 points, I got a dot. At the third half-life, half of n0 by 4, that is n0 by 8, that gives me third. Then again in the next half-life, let's say after 10 years or whatever it is, again I will get one more position. Again one more position. Again one more position. When I join all these things, the graph is between time period and the number of atoms present at that instant. I will get something called as an exponential curve. And this exponential curve itself proves the formula. N is equal to n0 e raised to minus lambda t. Dear students, this idea is of the radioactive decay. As you can see, the large number of nuclei converting into smaller number of nuclei. But they never go unfinished. They always remain. Okay, that's the crux. So this expression gives the number of nuclei at a given instant. Radioactive substance decreases exponentially with time. Agreed, but it never vanishes away. So what is half-life? Half-life is that period of the time in which half of the substance is remaining and half has already been decayed. Simple and sober. We have n is equal to n0 e raised to minus lambda t. Now when your t is half-life, your n becomes n0 by 2, half of initial number. You put this value in this equation, you cancel n0, what you get is 1 by 2 is e raised to minus lambda t. You bring e down, so e raised to lambda t is 2. Now you take e on the other side, so lambda t is natural log of 2, that is 0.693. And if I want to find out half-life, hello, that is 0.693 by lambda. So this is one such expression of half-life. We can determine the different half-lives for any given radioactive substance. Now, to end my module, let me give you another formula. Apart from n by n0 is e raised to minus lambda t, that formula is somewhat like this. Let's say, number of half-life, the amount of substance remaining, and the formulation. When time was 0, just start, your n was n0. I can write this as n0 half raised to 0. You say, sir, why are we doing all these things? Why half raised to 0? Simply write now, n is equal to n0. No, just wait. When your time is first half-life, it becomes n0 by 2. And n0 by 2 can be written as n0 into half raised to 1. Then for the third half-life, or I mean say before that second half-life, n becomes n0 by 4. That is n0 half raised to 2. Third half-life, n0 by 8. That is n0 half raised to 3. Similarly, fourth half-life. Similarly, if I say nth half-life, so my n will directly become n0. See, for 0 it was 0, 1, 1, 2, 2, 3, 3. So for n it will be half raised to n. That is where the general formula comes. Ladies and gentlemen, general formula states that n is equal to n0 half raised to n, where n is number of half-lives, also given by small t upon capital T. Okay? How? Look at that. Small t is n into t. So n is equal to small t upon capital T. So if I generalize this entire formula, n by n0 will be equal to half raised to n, that is equal to half raised to small t by capital T. This entire formula is the alternative method for your given solution. I hope it was clear and you understood the module. I will see you again with more numericals and more theory.